Given question, two copper rods and one steel rod together support a load. For the given allowable stresses, find the safe load that can be supported.
This is the question of compound ties or struts because two different materials are fastened together. Now if we observe this question, then the total load P is shared by these two materials. But if we observe, there is one steel rod and there are two copper rods. So we can say that this total load P is equal to P steel plus twice of P copper because there are two copper rods. So this is the first condition we have to write, that in case of compound ties or struts, that is the total load is shared by the two different materials. So P is equal to P steel plus twice of P copper. Now how to write this load in terms of stress sigma? So we have formula P steel, that is stress sigma steel multiplied by cross sectional area of steel rod plus twice of P copper, that is twice of sigma copper multiplied by area of copper. So we will give here this equation number 1. So here on left hand side we will write P. Now in case of compound ties or struts, we have the second condition, that is the strain produced in material A is equal to strain produced in material B. But if we observe, the length of each rod is different in this case, but the total load P is shared by these two materials is same. So we know that strain is equal to change in length by original length. So this original length of the copper rod is different from the original length of the steel rod. So we cannot say the strain produced in steel is equal to strain produced in copper. But if we observe the diagram, then we can say that the change in length delta L should be same for each rod. So we can say that delta L for the steel is equal to delta L for the copper. So how we can write this delta L? So we know that strain rho is equal to delta L by L. So we can write here delta L is equal to strain, that is rho, multiplied by original length L. Now we will say that this rho steel multiplied by L steel is equal to rho copper multiplied by L copper. Now we will put the values. So if we observe, we know the length of the steel rod and length of the copper rod. So I can take this rho copper to the left hand side. So we will get the ratio of strain in steel divided by strain in copper is equal to. So we have to take the ratio of lengths and it is equal to 0.75. Now how to write this strain in terms of stress sigma? Because we have to first find out the stress in steel rod as well as in copper rod. So we can write the strain is equal to stress divided by Young's modulus. So I will simplify this. So strain in steel rod is equal to stress in steel rod divided by Young's modulus in steel rod, divided by strain in copper rod, that is stress in copper divided by Young's modulus in copper rod. So I will take this denominator term to the numerator, so it will become E copper divided by sigma copper, and this ratio will remain same. Now the condition is given that Young's modulus in steel rod is twice of Young's modulus in copper rod. So instead of this steel rod, if I put this relation twice of E copper, then here I will write here twice of E copper. Then this E copper is getting cancelled and here will ratio 1 by 2. So sigma steel by sigma copper into 1 by 2 is equal to 0.75. So we can say that sigma steel is equal to 1.5 sigma copper. So this is the second equation we will get. Now we will cross verify the safe stress which is mentioned in the question by using equation number 2. So the stress is given for steel is equal to 100 into 10 raised to 6 Newton per meter square, and for copper 50 into 10 raised to 6 Newton per meter square. Now for steel, if we consider, it is equal to 100 into 10 raised to 6 Newton per meter square. So when we put this left hand side 100 into 10 raised to 6, then stress in copper we will get 66.6, and it is more than safe stress of the copper. So if we compare these two values, then it is more. So safe stress in copper given as a 15 to 10 raised to 6. So we cannot use this value for this safe stress 100 for steel. Now we will move to the next. We will take the safe stress for copper is 50 into 10 raised to 6. So when we put on right hand side this value 50 into 10 raised to 6, then we will get the safe stress for steel is equal to 75 into 10 raised to 6. So if we compare the safe stress for steel and this calculated value, then this 75 is below that safe stress. So we can use this stress in copper as well as stress in steel. So when stress in copper is 15 to 10 raised to 6, that time we have to take the sigma for steel, that is stress for steel is equal to 75 into 10 raised to 6. Now we will put the value, these two values in equation number 1. So we have the area of steel as well as area of copper, that is this is the cross sectional area and it is mentioned in the question. So when we put the values, then P is equal to, so we will get the value as 0.0525 into 10 raised to 6 Newton. So when we simplify this, then we will get 52.5 kilonewton.